All right, so last time we talked about coterminal angles, and we sort of, conceptually figured out that in order to find a coterminal angle, if you're at a point, if you're in an angle on a circle, in order to find a coterminal angle, we either added or subtracted 360, or we added or subtracted 2 pi. And we're going to continue working with that today. And so just to, solidify that, to find a coterminal angle in degrees, we add or subtract multiples of 360 is what we said, right? Because you could add 360 once, twice, 3 times, however many times you want. Because if I'm at a point, I could go and circle once, twice, 3 times, I could still get back to the same point. And then if I'm looking for a coterminal angle in radian, then I add or subtract multiples of 2 pi. And that's it. And one thing I want to make clear is, on a test or a quiz, this is like the unwritten law of the land, right? If a question is given to you in radian, you're going to work in radian the whole time. If a question is given to you in degrees, you're going to work in degrees the whole time. And I always get this question of, well, can I convert to degrees, do the work, and then convert back to radian? And the answer is, mathematically, there is nothing wrong with that. However, this is trig class. And if in trig class we don't get over our fear of working in radian, then what's the purpose of us being here? So yes, the requirement is to answer that question, that you must continue working in radian. I want to see that work, okay? All right. So here, yesterday or last time, we looked for one positive and one negative coterminal angle. Here, notice what it says. Identify all angles that are coterminal with the given angle. So, if I take negative 30, right? How do I get a coterminal angle? I do negative 330 plus 360, right? And then I could also do negative 30 plus 2 360s, right? Is that right? Mm-hmm. What's another way to write that? Negative 30 plus 2 times 360. Or I could do negative 30 plus 360 times 3, right? So you could keep going, right? I could add another 360, and then I'll be negative 30 plus 3 times 360. Or it could be negative 30 plus 5 times 360, or 100 times 360, right? So I could add any number of 360s that I like. I could add 360 times whatever my age is at that moment, right? So in general, I can write that as negative 30 plus 360 n. What that n means is you could add as many 360s as you like. All right? Now, could I also have subtracted 360s? Yeah, I could also do negative 30 minus 360 times n. And that's too much writing to write those two lines in the end, and it wastes so much more lead. So I can condense it into plus or minus, and I could just say negative 30 plus or minus 360 n. So these are all of the coterminal angles. This is telling me take 360 and add as many 360s as you want, or subtract as many 360s as you want. Okay, so those are all of the angles coterminal with a given angle. Then find and draw one positive and one negative angle coterminal with a given angle. Can we do that part? Let's see. So now, to find one positive coterminal angle, I'm going to do negative 30 plus 360, 330, and a negative 1, negative 30 minus 360, how much is that? Negative 390. All right? So this here in the purple, it was just work for us to reason through. You don't have to do it every single time. What you will probably do is the thing in the black and then just the blue boxed one you could just come up with on, in one shot. How do we draw one? To draw, you're going to do an X and Y axis like this. And now here is the initial side. And now I want negative 30 degrees. So just draw here. Okay. So 3 pi over 4. We want all of the angles that are coterminal. So what we could do here, we could add or subtract multiples of 2 pi. So it'll be 2 pi n. And that's it. Okay? So these are all of the coterminal angles. Now, if I want one positive, I add 2 pi. This is what you were doing over the weekend for homework. And if I want a negative, I subtract 2 pi. So go ahead and find the positive and negative for these. All right, so I'm seeing lots of 11 pi over 4s. And lots of, what for the negative, what did we get? Negative 5 pi over 4. All right, so 11 pi over 4, negative 5 pi over 4. And how would I draw a 3 pi over 4?
No.
Right, and it's not, is it 180?
No, it's the lowest.
So, right, so each one of these squares is a half pi, right? So half pi, full pi. Here I have 3/4 of a pi. So 3/4 of a chocolate bar, right? You've had more than half, but not quite all. More than half, but not quite all. Okay. Yeah, and so that's 3 pi over 4. All right.
Oh, so you don't have to do like this.
No, not for these. It becomes redundant. I might just ask you, just like that on the quiz, to draw 11 pi over 4. Yeah. You do. The 11 pi over 4 you do. Yeah, we're going to practice with that today. Okay. Arc length. So, okay, so listen. When we are working with these, there's a little bit of a pitfall. Like, there's a small pitfall here. When we use, so a full pi is right here. When we visualize around like the edible pie, then it gets us into trouble because unfortunately a pie is a circle, but a full pie here is only half a circle. So in all my examples, it comes a point like starting now where I no longer choose round things for these, like pizzas or a pie. I go with a rectangular chocolate bar because if I say, like if I use the example of a round, or if you use an example of a round object, like a pizza or a pie, then you're going to think it's the whole thing. So think of it as a chocolate bar. This is a full pie, right? It's a full chocolate bar. 3/4 of it is more than half. So that's easier for us to visualize. Okay, let's talk about arc length. Remember before we were talking about having that circular track? And we were walking along that track. Arc length is any time you walk along a circle, okay? It's distance walked around a circle. And it could be either partial or full. So if I only walk this much around the circle, that's arc length. All right? How do I find arc length? It's a simple formula, S equals R theta. The only thing is, here it is. This is S and it's arc length. It's that distance. R is the radius. And then the one thing you must watch out for is theta is the angle and it must be in radian. Okay? All right, so it's basically 3 elements in a formula, S, R, theta. You will be given 2 and you need to solve for the other. So let's take an example here. It says here to find the length of the intercepted arc. In this formula, which one is that? S, R, or theta? S. With the given central angle measure, so that's theta, and radius is R. Round to the nearest tenth. Okay, so here we go. This is my angle theta, the 2 pi over 3. Is that in radian or degrees? It's in radian, so I don't have to do anything. I'm good to go. So now I just say S equals R theta. S equals R, which is 2, times theta, 2 pi over 3. The whole 2 pi over 3 is the theta, this. So now, S equals 2 times 2, 4 pi over 3. Now what we're going to do is we're going to put this in our calculators. So go ahead and take out your calculators. All right, and we're going to plug that into the calculator. So it's 4 pi over 3, right? So what I'm going to do is hit 4. The pi button is on the bottom left. If I hit that, I get a window of all sorts of choices. Pi over 3, enter. Make sure that that's what you want, right? 4 pi over 3, and that's your answer. Yeah. Because it says here to round to the nearest tenth. And so it's going to be 4.2. So S is about 4.2. All right? Okay, here we go. This next one, I have an angle theta of 135 degrees. That I need to convert to radian. So first I convert to radian. Convert to radian first. So I'm going to do 135 times pi over 180 is my theta. To find if you're going from radian to degrees. So now, if you're using this as part of a solution, you could even just leave it like that, all right? And you could do this. S equals R theta. So now what was my theta here? It's just 135 pi over 180, right? So if it's an intermediate step, you don't have to. It'll minimize some work for you. So look at what I'm going to do. S equals, R is 0.5 feet times 135 pi over 180. So I'm going to go into my calculator and I'm going to say 0.5 times. In the numerator, I have 135 pi over 180. You can if you want, but then it's more work, and then what happens is when you're rushing, like you might transfer the wrong number and blah blah blah. Okay. If it's, yeah, if you probably just ask us to do that, then yes. Okay. Okay. I see some people with calculators, but not everybody. Please make sure that you bring your calculator across with you every day. What text later? If you let's do this now. Oh. Okay, so S is 1.2. Okay, now look. I have a unit here of feet, right? So my answer here has to have feet. Okay? All right. Okay, so now let's go to area of a sector. If I have an angle in a circle like this, and I make an intercepted arc like this, this part of it only is my arc length. That's what we were looking for. That was S. Now, the entire thing is a sector. So what if I needed to find the area of this? That has its own formula, and it's half r squared theta. All right, so let's find the area of a sector with the given central angle and radius. Again, theta has to be in radian. All right, so let's do this one. Theta is in radian here. We need to find area. It's half r squared theta, half r squared is 1.5 feet squared times theta. Okay, now I need to put this in my calculator. So go back to your calculator. The formulas? No. So it's these two that you need to know. It's S equals r theta and then half r squared theta. Yeah, like they'll give in the beginning in the problem, but not the formula. Okay, so take a look here. We need to transfer this into the calculator. So it's going to be 1/2 in parentheses 1/2 times 1.5 squared times, let me make this bigger, in parentheses 3 pi over 4. All right, enter. Just make sure that this print looks like what you have on your paper. So we get 2.65, which is about 2.7. And now what are the units? I have feet squared. All right, go ahead and do the next one, please. What do you have to do first for the next one? Convert to radius. So go ahead and do that. Okay, so I need to find the area of the radius in this next problem. I'm sorry, I need to find the length of the radius, and I'm given area. So I start with the formula for area, half r squared theta, and I'm going to substitute everything that I have. I'm given area, which is 190, equal to 1/2 r squared times theta is 5 pi over 3. Okay? Now, this is 190 equal to, if I combine these two, multiply the numerators, I get 5 pi. Multiply the denominators, I get 6 times r squared. How do I get rid of the 5 pi over 6? Divide or multiply by the reciprocal, 6 over 5 pi. So, r squared is equal to 6 over 5 pi times 190. Let's go ahead and put that in. It's going to be, I'll just do it here. It's going to be in parentheses 6 over 5 pi times 190. Okay, so let's see if that is that a correct way of entering that information. Is that correct? No. So what? Pi has to be in the denominator as well. So what I should have done is 6 over, in parentheses, 5 pi times 190. So it's 72.6. All right, so look at what I do. I say r squared is 72.57. Now, I need to square both sides, right? But here in my calculator, I don't type the number again. I just say square root of the answer. That way, I get the full-blown answer in there, and it's 8.5. You press square root, and then to put answer in there, you do control the negative button, and it just takes the previous answer and just puts it in there. It's magical. So that's 8.5. I'll show you. So R is about 8.5. What are the units for R? Feet. So one more time. Anytime you want to input an answer. So basically square root, just like always. And then you have to do control. And if you go and look at the negative button to the left of the enter button, on top it says ANS for answer. So that says take the previous answer, the full-blown answer, and put it in there. It's very, you get so much error when you start rounding, and then when you take a square root of a rounded answer or square a rounded answer, forget it, okay? This is how, NASA, loses their Mars polar line. There's this, they make errors like this. Yes.
So when we get to the first equation before we start doing anything, you don't want us to multiply, to just plug into our calculator 1/2 times 5 pi over 3. And then get a decimal and divide that by 190.
You could do that. That's mathematically right. As long as you're not rounding, you're always doing 190 divided by answer divided by, yeah. But show me this work. On the test or quiz, I would like to see the first two steps, right? I want to see the work. I don't just want the answer because you have to justify where these come from, all right? Now, this is the homework for next time. Right now, what I would like you to do is take out the sheet with those circles. Yeah. We did last time, right? we finished. Oh. Yeah, this I want to do because this is so important. And if we don't go over angles, drawing angles now, I feel like it's too late to do it later. It's worthless to do it later. All right, so we did a couple of these. We're on page 2 of this. What I want you to do for each of these, so you should draw the X and Y. Now, on a test or quiz, if I ask you to draw an angle, I won't give you the circle, but you would have to do the X and Y axis. Okay, so for negative 33, right, you have to show me the initial side. Negative 33, we're going to go this way a little bit, down, clockwise, here, and then you say negative 33 degrees. I need at least to see these 3 arrows. If you don't put the negative 33 in here, that's not a deal breaker, but those 3 arrows must be visible. Okay? So here, negative 215, am I going to go up or down? Down, how much? To the, yeah, to here, basically. It's 3 quadrants here. Okay, right there. 410, I start here. How much? I'm going to make a full circle, that's 360. And then how much more do I need to go? About 50, right? So right here. Yes. So this is how I would like it to look. I want to see that you need to go a full circle and then one more. A little more. Okay. Now for the radians. Believe it or not, I find it's easier to actually draw angles in radian than it is in degrees, because in degrees, you're doing all this math, like minus 360, minus 360 more. With radians, it's so much simpler, and I'll show you what I mean by that. Okay, so here's what we're going to do. Again, I mentioned this before, I think, but this is the only time in my life when I use mixed numbers like we did in middle school. So here I have pi over 3. How much of a pi is that? It's a third of a pi, right? Pi over 3 is a third of a pi. So here's what I do. This is my initial side. How much is a pi? If I go over here, that's a full pi. I need a third of a pi. So this middle here is half a pi. To draw a third of a pie, okay, imagine a third of a chocolate bar. If you have a third of a chocolate bar, have you had more than a half or less than a half? Less than a half. So if this vertical is the half, a third of a pie is less. So we're in that quadrant right here. That's it. Okay? Now, here I have 2 pi over 3. I write this as 2/3 of pi. Here's my initial side. Okay, if I go all the way to that other horizontal side, that's a full pi. So now, 2/3 of a chocolate bar, is that more than half or less than half? More than half, so I pass the half and go here. That's 2/3 of pi right there. Okay. All right. This is 3/4 of a pi. Initial side. Again, each corner is a half. So, if I want 3/4, do I pass the first corner or no? I do pass the first corner because 3/4 of a chocolate bar is more than the half. So I'm right there. After after a while, that will not be very helpful. Like, now is the time to get comfortable with them, because if you're still not comfortable, like after a while, it's gonna get you into trouble. So we might as well. With enough practice, I think we'll get it. I prefer that we are more comfortable with gradient. Okay, let's do this one. I write this as 7/6 pi. Okay, now what's 7/6 in mixed number? 1 1/6 pi. Okay, so now here's what I'm going to do. I'm going to draw them in parts. Okay, so first I'm going to draw this 1 pi. So I go here. How much is a pi? Right there. Then I need another 1/6 of a pi. How much is 1/6 of a chocolate bar? Very little or a lot? Very little. So after this, I go just a little more, 1/6, and I'm right there. Okay, so do you see how I divide and conquer? First the 1, then the 1/6. Okay, how about this one, the 5 pi over 3? Yeah, it's 5/3 pi, which is 1 2/3 pi. So, first I draw the 1. Now, I need 2/3. How much is 2/3 of a chocolate bar? More than the half, right? So look, from the horizontal here down here, that's a half. 2/3 is more than that, so I go here. All right, how much is 11 pi over 4? 11 over 4 pi, 2 3/4 pi. So, this is my 2 pi. Is that right? Now I need another 3/4 pi. Half a pi, 3/4 of a pi, right there. All right, so we have about 2 minutes. Do the next two. Convert to mixed numbers. What's 23 over 3? 7 2/3 pi. So you're going to go 7 pi and then another 2/3 pi. This part used to be so confusing to me when I was first learning them. So if it's confusing now, that's okay. I was never taught it the way I teach it now. But, still, I find they're not like, because it's the first time we're ever doing this in our lives, right? So 7 pi, look. 2 pi. 4 pi. 6 pi. 7 pi. It's important that, you end up on the right, or, correctly on the right or left. 7 pi. Then I need another 2/3 pi. So do I cross that?
Yeah.
Yes. 2/3 pi. And I'm right there. And that's how I need it to look. Okay? All right. I'll let you guys go. Homework.